Hi everyone. This week we introduce the topic of logic models and how to create them for your program. Your reading this week is Fennell and Rogers, Chapter 9, and there are some additional articles posted on Blackboard if this topic is interesting to you and you want to learn more, or that you're just looking for some more information to better your understanding. Basically, a logic model is a visual representation of your program and how it works. The book focuses on 4 different approaches: the pipeline model, the outcomes chain, the realist matrix, and a narrative logic model. These are certainly, although they are kind of models to start with, they are not absolutes. There are certainly other ways to do a logic model, and some aspects of them can be combined as necessary. However, these are just some key designs that might be useful in helping your thinking about your program. What makes a good logic model? You have to show a coherent causality, so how the activities of your program are going to contribute to the outcomes that are desired. A logic model must, in fact, be logical. Again, it has to make sense. People have to be able to understand, looking at the visual depiction of the program, how it works. And along those lines, communication is key. So using words that are appropriate to the audience, the intended audience for your model, as well as just making sure the correct information is on the model itself. So some key points to remember in developing a logic model is really the model has to explain how the program contributes to the desired outcomes. There has to be a flow. The cause has to be apparent. You should avoid dead ends, so you should not have activities that don't lead to anything and don't contribute to the outcomes in some way. Along those lines, every arrow in your model or connector should mean something. You don't just have boxes connected for no good reason. Everything should imply a process, and to that end also have a directionality. Some things are bidirectional, but certainly some things are not, and you have to be clear about the direction of change. Things should be shown sequentially, and which pieces are expected to be consequences of other steps. So for instance, in some cases, certain outcomes need to be achieved before later outcomes can happen. You want your model to focus on the key elements of your program. So sometimes we have to get really focused and consider the scope to make sure our logic model makes sense and is clear. To that end as well, we don't want to overdo our arrows and feedback loops. Sometimes just because one thing can inform another doesn't mean we need to have arrows for everything. We really want to communicate the key aspects of the program. And so to that end as well, we want to remove anything that doesn't contribute to that goal. Readability is very important. So while you want your logic model to be comprehensive, you also want it to be legible. And you want people to be able to read it, so we want to avoid very small print or things in shapes that aren't really visible, or colors that don't really work visually. And also avoiding acronyms that people might not be familiar with, especially if you're using your logic model to communicate to a wider audience. And sometimes being careful with choices of language, not using terminology that could be offensive to some of the parties who are going to be using your model. So those are just some key points and some introductions. So go ahead and read that chapter, and we will apply these concepts in the next couple of weeks in developing a logic model for your own program.